and I'll label it geometry so that you guys can find it pretty fast. All right, so we're recording. Oh, let me share my screen. I'm not sure if I have to do this, but let me do it anyway. There we go. So if I go to YouTube, oh, actually, I'm sorry, I don't even need to do that. Here. So on the bell work, you see how I've always had that picture right there? That's what you're looking for on YouTube. That's my little icon for Mr. Gill. So you type in Mr. Gill. I have a period there, so maybe it's better to put the period. It does matter, but there is another Mr. Gill that teaches algebra, apparently. So you could potentially find him. That's why you want to look for the picture of my dog. And then that'll be me. And I've got a whole bunch of videos. He's only got like one video. I've got like 40 videos. Like I said, they're all algebra videos for the most part. Some of them are actually not algebra, but they're just videos about math and things that have been confusing to kids over time. So I'll put this in that same place. Go there. If you really want to look at it and review, you can review using that. All right, so here's the figure. We are at -1 and then 4. So I go to -1 on the x and then +4. Oh boy. It's not going to be a perfect because it's not super well. Let's do this. So hopefully will help make it a little bit more precise. All right. So -4, or I'm sorry, -1, 4, 2, 0. Oh yeah, perfect. And then 5 and 3. All right, so that's my triangle. And it says reflect in the x-axis. All that means is you're reflecting it over the x-axis. In doesn't, I don't know why they use the word in that problem on the quiz, but that's exactly what it says, is in the x-axis. So the terminology would be r at x-axis, which I don't think she uses that. Yeah, she doesn't use that. I put it there, and I'll probably like manually remind you, but basically just means you're flipping it over the x-axis. So the x-axis is this right here. So all we need to do is flip it directly over that. You have rules for this. If you look at your second page of that sheet that I told you to have out, it specifically says if you're flipping over the x-axis, so it gives you this terminology, then this is what you do. And basically all we're doing is we're flipping the signs of the y variable, or the, not really variable, I mean, I guess it is variable, the y part of that coordinate. So I'm really just changing this. Now the 0 doesn't really have a sign, so your 0 would still be the same coordinate. And then your 3 would have a negative, your 4 would have a negative. I'm going to visually do it first, though, and then we'll come back. Because like I said, you can always draw a graph yourself and do it if you like it. So when I visually do it, we'll do it in a different color. The 0 stays the same. This point stays right there. Each point needs to be the same distance from that x-axis when I draw it. So if I was 3 above the x-axis, I need a point 3 below the x-axis. That's pretty cool. So there, I need a point 3 below. I'll make this one actually. If I'm 1, 2, 3, 4 above it, I need 1, 2, 3, 4 below it. So that, if I just visually did it, would be my triangle. And I would get 2, 0. What is that? -1, -4. And +5, -3. So that should be what we get if we use the rule. So let's just make sure if we use the rule, we get the same thing. So again, we just flip the sign of the y is what it says. The rule in your sheet. It says change it from this. Change it from that to this. You don't change the x, you just flip the sign of the y. Well, if that's what we do, if we're just flipping the sign of the y, we'd get, so this would be a prime, be -1, -4. B prime would be 2, 0, because flipping the sign of 0 doesn't do anything. And then C would be, we don't change the 5, the X stays the same. We flip the sign of the 3. Again, we don't just make them negative, we flip the sign. So if we would have had a negative sign, it would have flipped to positive. Now we can check and see if we got the same thing. 5, -3, 5, -3. -1, -4, -1, -4. 2, 0, 2, 0. So I don't care how you do it on the quiz. If you want to draw a figure and visually create it and then write the points from that figure, you do need to give me the coordinates, though, as your final answer. You need to understand once you draw the figure, you're not done. The coordinates are the answer in the problem, meaning the X and the Y, like all of these. That's the answer, not just the drawing. Any questions on that? That's the very first problem on the quiz. Different figure, different points, but pretty much the same problem. All right, next. That was where I meant to do it, apparently. So here's what's on it. If you want to take a picture of that real quick, take a picture of it. This is recorded, but if you just want to take a picture of it. There's a little more than that, but I'm going to go over it if it's not on that list, but that's the majority of it. Like, for example, if you look at number 6, it just says do transformations of figures. There are several problems for that. That just means they're going to give you a figure and they're going to say rotate this figure this many degrees, or reflect this figure, or translate this figure. So number 6 has several problems, like the first one we did, reflected over the X. That would fall under this number 6 here. I think there's probably 5 or 6 of those where they just give you a figure or they give you coordinates and you have to create the new figure or the new coordinates. Number 5, I'm not going to probably go over that. I don't think we'll have time, but that's old material. When we did line segments and we said, find the point that is 2/3 of the way from A to B, or find the point that is 1/5 of the way C to D. That's what number 5 is. So you'd have to use old notes on that. So you may want to go back and make sure you have your old notes in your notebook for that day. And now we'll go over all of these other ones. So the next question on there, the vertices of a triangle are, and then it gives you the triangle, and then it says name the vertices of the triangle when it is y equals x. We have not done this at all yet. So this will be probably the most confusing thing we do. We flipped it. This is a reflection, right? Big R is reflection. So we flipped it over the x-axis. So we've done this. We flipped it over the y-axis. Right? I don't even think we flipped it over a number. That's really the main. We did actually flip it, I think, over at x equals a number and a y equals a number. Like x equals 2 or y equals -1 or something like that. We're going to do those today too, just in case we haven't. We haven't done this where we say y equals x. The rules are on your sheet. So again, you just follow the rules. Whatever the original coordinate is, that's the xy. If you don't have this rule sheet, you better not be shy because you need to have it for a quiz.
I need more.
Yeah, I knew somebody did. I may not have enough for everybody, so look to see if you got it first.
Pretty sure.
Because this pretty much is the entire quiz, knowing how to use this rule. If the first time you try it is on the quiz, you're going to be in trouble. Anybody else? You got to give these back if I just handed it to you. I can let you use them on the quiz day. Well, next class. All right, so look at the rules. The second page. It says, the third, under the very top set of rules for reflections, the third one is y equals x, which is what we're doing right here. So we haven't done it, but all you're doing is following the rules. So if I'm flipping it over y equals x, it tells me I just take each point, and all I'm doing is I'm just changing the order. That's what that last part means where it says y comma x. I just take the y value and I put it where the x is. I take the x value and I put it where the y is. That's all you're doing. You're not changing any signs, you're not flipping any positives or negatives. You're just moving the x to where the y is and the y to where the x is. So all you have to do, and I'm going to show you why this works in a second. If it confuses you, then you can just forget about it and follow the rules. So I'm literally just changing each point. So that'd be prime. Y prime would be 2 comma negative 3. And z prime would be negative 2 comma 1. All I do. If they gave you a graph, do they give you a graph? I don't think on this quiz they give you a graph and then they ask you to do that same thing. All you would do if they did though is just write the points down first. So take the points from the graph and write them down in that format, and then you would just flip the order as your next step. Yeah, they give you some graphs where you have to actually graph stuff, like do a transformation, but you don't have to worry about that. So that's all you do for that problem. Follow the rule on the sheet, change the order. Now, if, again, I'm not necessarily giving you the exact same problem. If it's not y equals x, and it's y equals negative x, then you follow the other rule, which is right below the one we just talked about. So if it's y equals negative x, so let's say that's what it was. Hopefully you already wrote that down. Anybody still writing that? You got to keep up because I'm moving fast today. I mean, actually, you know what? I got to go. This is recorded. So you can go to my YouTube if you didn't get that down. I want to make sure we get everything done. Then if we get through it and we have time, I can go back and you can ask me questions. Let's say it wasn't that. Let's say it was this. Y equals negative x. Well, now we just look at the rule right below. So the fourth rule says y equals negative x. All it says is we take the original point, we flip them again, but this time we change to the opposite sign. That's what the two negatives mean. It doesn't mean make both of them negative. It means flip the sign of both of the numbers. So again, x prime, we flip the 5 and the 4. Well, negative 5, negative 4. But we also need to flip the sign, which in this case, they're both negative in the original one, so they'll actually both be positive. I didn't need all the spaces. So let's rewrite that. So again, here's what I'm doing. I'm looking at the fourth rule because we're doing y equals negative x. That's the fourth rule under reflections. It says take the original coordinates, x and y, flip the sign. That's why there's a little negative on the y and a negative on the x, all the way to the right where it says new coordinates. It says flip the sign and flip the order, meaning put the y where the x is and the x where the y is. So that's your new coordinate. And then you just do that for everyone. So y prime, again, I flip the order. I flip the sign, though, of the 2, so that becomes negative. I flip the sign of the negative 3, so that becomes positive. And then I flip them to where the 2 is now the first part and the 3 is the second part. The negative 3 is the second. And then I do the same thing for the z. So positive 2 and then negative 1. Any questions on following that rule? I don't have a whole lot of practice ones. We have another one, I think, on here that we're going to do where I may show it to you. I've actually got a whole lesson on it, but I'm going to skip the lesson for now, and we're just going to stick to the rule sheet. And if we have a bunch of time, I'll show you the lesson real quick at the end. Everybody's good? You can follow the rule sheet. This quiz shouldn't be real difficult. So if you're not sure, you need to ask questions now. Don't try to ask them during the quiz tomorrow. So next, find the image. Find the image of P coordinate -3, -2 after two reflections. The first is R equals -6. The second is R, a reflection of over X equals 2. So again, this means a reflection over Y equals -6 and a reflection over X equals 2. We haven't done a lot of this, so I'm going to slow down a little bit here. We're not just reflecting over the X or the Y. When we reflected over those, we just had to change the sign of one of those numbers. If you look at this sheet, there's not really a rule for this. So I'm going to spend a little more time on this one. So everybody look at the sheet. There's no rule for reflecting over Y equals some number or X equals some number. So this is one where you might want to visually draw a picture, a graph, or use graph paper, and I'll give you graph paper. So anyway, our point is -3, -2. So let's go over to a graph. First, like I said, draw a picture. Oh boy, I forgot. -3, -2, right? Yeah. So I take my graph and I just plot -3, left and right first, then -2. So that's the point. There's not a triangle or a rectangle or any of that. You just got to do one point. Because remember, moving a figure, moving a shape is just moving each individual point separately and then connecting them with lines. So it says first, reflected over Y equals -6, and then reflected over X equals 2. So what does that mean? Well, it means we have to find the line where Y equals -6 first. Does anybody know what that looks like? What's it look like? Close. It's not -6 on the x-axis. It's actually -6 on the y-axis. So we need to come all the way down, and here's a little bit of a problem on this. If you'll notice, I'm going to have to zoom out actually. And this is exactly what happens on the quiz, by the way. I created this one just to give you the same challenge you're going to have on the quiz. I'll go to that one. So y equals -6 is right here. It's a horizontal line. Anytime you have y equals a number, it's always a horizontal line. If you have x equals a number, it's a vertical line. So if you don't remember that, you need to write that. This is y equals -6. Again, y equals just some number is always a horizontal line, and whatever that number is. So I need to reflect this over that line. Problem is I go off the graph. Now you can always extend the graph, which is what I'm going to do, but there's also another mathematical way to do it. So if I extend it, again, this does not have to be perfect. Your graph does not have to be perfect. You just need to, in your head, be able to visualize it. So just say, all right, well, I'm going to make this a larger graph. 8, 9, 10, 11, 12, 13, 14, 15. You can go as far as you want to. I'm not going to write the negatives in. Hopefully you understand that these are all negative. All right, so now I've gone all the way down to -15. I need to take this dot and I need to reflect it over that line, which means however far away I am from this line, I need to be the same distance on the other side of the line. That's what a reflection is, because remember, there's no rule for this. So if I am 1, 2, 3, 4 away from the line, then I need to be 4 away from the line down here. So again, 4 would be 1, 2, 3, 4. So I would be at -10. Did my x value change? All right, I was here. I was at -3. I'm just flipping it over the line. Now I'm just at -3 comma -10 now. So this was -3 comma -2. My x value will not change if I'm flipping it over any y number. I'm just flipping it up and down, not left and right. X does not change. So write that in your notes. If you flip over y, x value doesn't change. And it kind of says that in the rule when you flip it over the x-axis. Because technically flipping over the x-axis is flipping it over y equals 0. That's another thing you need to know on the quiz. The x-axis is the same thing as flipping it over y equals 0. So reflecting, whenever you see this, y equals 0, that just means you're reflecting it over the x-axis. It's the same thing. So my new coordinate then, and won't be done yet, but it's -3 comma -10. That's my first reflection. But remember, we have to do 2 reflections. We're not done. The next reflection, I'll do it in a different color even. I need to reflect it now over x equals +2. If you have x equals a number, that is a vertical line. So that is now our reflection line. X equals +2. So again, in your notes, say if we are reflecting over x equals something, that is a vertical line through whatever that number is. X equals 2. I draw this whole thing out. Boy, I guess if you really want to come up, it's a little late, but if you want to come up and grab some graph paper, that's probably not a bad idea, because we're going to be doing more graphing stuff. I'd use these. If anybody wants these, here, if anybody wants to grab graph paper, there's some there, and then here's some over here. If you take any notes, I've been watching you get your phone. So, okay, so this is all recorded, so I'm going to keep moving forward. All right, so again, x equals 2 is a vertical line. Y equals -6 is a horizontal line. Do not get that confused with this. A lot of times people will think, oh, well, that's x. There I got an x, so that's going to be a vertical line. Well, no, it's the x-axis. That's the same thing as saying y equals 0. This, flipping it over the x-axis, that line, is the same thing as flipping it over y equals 0, because y is 0 at that point. So these two things are the same. Same exact thing. So write that in your notes. Reflecting over y equals 0 is the same as reflecting over the x-axis. And by the same token, I'll write it in red, these are the same things. That's the same thing. Because the y-axis, the vertical line right here, is where x equals 0. So those are the same thing. You're going to probably have to pretty heavily rely on your notes on this quiz, so I hope you're writing some of this stuff down, most of it. Or that you go back and watch this later to clarify, because I know we're moving pretty fast. Hopefully we'll have some time at the end and we can come back and clarify some of it and spend some more time. All right, so I now need to do the second part of this, which is the reflecting it over x equals 2. It's the same exact process. How far? So I'm at this point now. This is where I did my first reflection. So I landed here. I need to reflect it now over x equals 2, this green line. So I need to know, well, how far away am I from that line then? Well, I'm on -3 and I have to go to -2. So 1, 2, 3, 4, 5. Or you can just subtract the difference. 2 subtract -3 would be 5. Key is you want to know how far away are you from this line. It can't be a negative number because distance is never negative. Oh, you get cough drop. Distance is never negative. So if I'm trying to measure how far am I from here to there, that is a positive number, and it's going to be 5. Because again, I'm going from here to there, which is 1, 2, 3, 4, 5. Does anybody have any questions on that? Like how I'm getting that distance? All right. So if I'm 5 away from this line on the left, when I reflect it over x equals 2, I just need to be 5 away on the right. So I just need to go from here and count 5 to the right. Is my y value changing? Ariana, are you awake? Melissa, are you awake? Right. Again, during a review, I don't babysit. Like if the grade is important to you, then you'll stay awake. You'll pay attention.
I understand.
Hmm?
I understand this.
No. I'm not. I'm saying that's fine. If you want to put your head down, I'm not gonna. I don't constantly wake people up. Is all I'm saying. I'll check every once in a while, just make sure you're awake. But if you got it, you got it. I don't care if you pay attention or not. I don't care if you take notes. You can get 100% on quizzes without any of it, and I'm fine with it. So 5 away on this side, which means I count 5 to this side. My y value does not change. I'm just flipping it directly. Perpendicular is really the correct word. I'm flipping it perpendicular to that reflection line, which puts me at 1, 2, 3, 4, 5 on the 7. Try to draw it as perpendicular as I can. So my new point now, again, my y value didn't change. So that's my new point. So and my final answer in this one. I just need to figure out how. So you don't really need, like I said, a perfect graph to be able to figure this out. Not like you're drawing anything in, and that the when you draw it, it's going to be dependent on, having a perfect graph. You just need an idea of where are you falling with each point, which this works fine. And this will happen on the quiz. It will fall off of the graph if you use this graph, unless you have your own graph paper and you want to make a bigger, much bigger graph. That's up to you. But my graphs only go up to the number 7. Bless you. And they go off of the graph with using the numbers they use on the quiz. Any questions on that? All right, go ahead. I think that's all on that. We talked about the fact that these are the same thing. Hopefully you wrote that down. We talked about the fact that the r reflecting over y equals 0 is the same thing reflecting over the x-axis. So I think that's it for that. I'm getting rid of it, so that's why I keep asking. Everybody still ready? All right, so the next thing that's on there. So we just did number 1. Actually, no, I'm sorry, we did 1 and 2. So you also have to know how to write the rule. So they give you an image. Oh, I'm sorry, they don't give you an image, they give you coordinates. So they give you 3 coordinates. That's what we'll come back to if we do that lesson. So they give you 3 coordinates in the quiz. And they say, what is the rule that reflects the triangle to its image? All that this means when it says reflects the triangle to its image, remember there's a pre-image and an image. The triangle is the pre-image. The triangle. What do we call that? The triangle is the original image. That's supposed to be triangle. But I'm making fun of the fact that I misspelled it. And then the image is just the second image. So you have a pre-image, which is the original triangle, these 3 points, and then the second image, which I need to probably put some spaces in that so we see it better. There, that's better. So they don't give you a graph, but again, just draw a graph. You can draw a graph. Does it fall outside my graph paper? Oh, it does. It does fall outside the graph paper that I have. So you'd have to extend the graph paper that I have or create your own. If you're really getting this, all you need to do is look at your rules sheet. So go to your rules sheet right now. What did I just do on my rules sheet? Oh, there it is. All you're trying to do is, instead of going from the far left columns to the far right columns, and again, this is only about reflections. This is still about reflections, so you're not looking at the bottom table down here. You're just looking at the top table. If you can figure out, well, what did they do to each one of these points? What's going on with each point? What happened? D'Anthony. What did they do to point A? Can you see it? I'll zoom in. So D'Anthony, what did it? Just look up here. Don't even worry about it. This is not that bad. I'm going to show you how to do it right now. What did they do at point? So this was my original point A. Oop. There. This is the original point A. This, so that's my pre-image point A up there, and that's my image. What did they do to the X and the Y? So they, first of all, we see the order change, right? So the original ones are always going to be written like that. Ignore negative numbers. When you do a problem like this, you don't write negative X and negative Y. The original numbers are always written as just X and Y. So you need to make a note on that, make a note on that. Because your rules sheet, if you notice, on the, oh, they don't even give it to you on the reflections like that. They do it in the rules for rotations. It's all, the first coordinates are always X, comma, Y. But this is how they're writing it. The first coordinates are always X and Y. The second coordinate is then either X and Y or negative X, negative Y, and it's just based on whether or not the sign is flipped. But the first thing you noticed is they did what? Say it again. They changed the order, right? Instead of it being 7 and 1, well, negative 7 and negative 1, they flipped it. So that's the first thing we know they did. Did they do anything to the sign? Did they change the sign? If they didn't change the sign, then you're looking for the rule that doesn't have any negatives in it. Because if there was a negative in it, then that would have meant they would have flipped the sign. So all they did was they changed the order and they didn't change the sign. So what's the rule? Which one of those rules under reflections matches that? Look it up and see if, actually, tell you what, I want you to write it down because I'm going to come around and check this all individual. I don't want any one person just yelling the answer out. So here's what they did. We said they took the original point. All you have to do is check one point, by the way. You don't have to check all three. Because whatever they do to one point, they're doing to all 3 points every time. Or 4, or however many points, whatever the figure is. So they just simply flipped the order. They did not change the sign, which means you're looking for this right here. No negatives, and just changing the X and the Y. So write down what you think the rule is. Which one of those rules is, and the rules are the far left part of that table. And I'm going to walk around right now. It's all these are, yeah, it says reflections right here. What is the rule that reflects the triangle to its image? We'll get to rotations in a second. Right now. All right. Oh, sure. I mean, again, it'll be fine for the quiz as long as you understand it. Not sure. Do you understand what I'm saying with that notation here? Okay. I want you to write it. Come back. Good. Yep. We're looking at it. Mm-hmm. Oh boy, a lot of you are not doing anything. Perfect. Yeah, if you can point it out real quick, that's fine too. You don't have to necessarily write it down. You can just show me and see what it is. Not sure? All right. You guys need to be, I'm literally giving you the test. This is the exact question. I just changed the numbers. That's it. If you can do this, you should get 100% on the quiz. Although there are some that we won't go over, but those shouldn't be hard. Oh, okay. I couldn't see the No. No, it'd be more than that. So look at, do you have the rule sheet? Yes, correct. Correct. Oh, out. All you're doing really is looking at this. You're on. I mean, you can if you want to try to do it that way, but that takes a lot longer. So try to do it without drawing it so you can get it. Did you do this? You gotta leave your phone if you go. Alright, put your phone in the phone jail up there and then grab the pass next to it. What do you mean by that? Where's your rule? Write the rule. Write the rule. Find it which one matches up with what I did the hard part for you. Not sure. Alright, I got a lot of people that either are not getting it or you're not trying. No rotation, this is reflection. It says, what is the rule that reflects the triangle? We haven't even gotten to rotations yet. That's in this time, I know you don't understand what I'm saying. Follow along. Alright? I mean, I did the hardest part of that for you. Good. Yes. Good. So when you are doing this, this is again the exact steps you will follow. And I'm not saying this is going to be the same answer. I'm saying these are the steps. You take whatever the original point is. So A is always the original. A prime is always the image. So I should say pre-image and image. I look at this original and I say that's my X and my Y. Always. You don't put any negative signs in the original. You will never, ever, ever have negative signs in the original. Now, I say, well, what did they do here? Well, the first thing I notice is obvious. They flipped the order. The second number is now the first number is now the second number. So I need to flip my order. Flip my order. When I'm going to go find the rule. The next thing I look for is, did any of the signs change? I mean, the sign means the positive or the negative. Did it change from positive to negative? Did it change from negative to positive? If it didn't change, then I don't do anything. I don't put any negatives there. Now, if this had been, let's say it was positive 7. So -1, positive 7. Well, then I still change the order because the order of the actual numbers is still changed. But one of the signs changed. Which sign changed? Yeah, the 1 is still negative. So the original second number, which was my Y, that I moved to the front, that didn't change. So I don't do anything with that. But this number did change. They flipped the sign, so that's when I would put a negative in there. If the sign flips, that's when you put a negative. And it'll only be in this second one. The first one will always be two positive variables, X, Y. But if the sign changes in the second one, that's when you need to include a negative sign on that particular number. And it could be both. This could have been +1, +7, and we would make both of those negative. Just remember, no negatives ever here, and then here you just have to figure out what happens, and if the sign flips, Then you put a negative, because basically a negative just means do the opposite. Flip the sign. And then if the order changes, obviously you change the order. Any questions? Oh, so what was the rule? A lot of you got it right, most of you got it right. The rule was what? What was it? Y equals x. So we reflected it over y equals x. So if you didn't get that, you may want to write it down to go back and try to figure it out later. We reflected it over y equals x. Because if you look at that rule, it's the third one again, we just did it. All they do is they just change the order. The y becomes the first part of the coordinate, the x becomes the second, which is what we wrote up there a second ago. They just flip the order. So let's do one more of these. I think I already have one right now. Do I? I might not. I may have to create one. Yeah, I have to make one. All right, so if, and this is another pretty tricky one. If they give us a problem, you're gonna probably have to do some work on this one after the fact. This is a lot longer than a quick review. There are problems in there where you have to figure out, is it reflected over something that doesn't have a rule? Meaning, is it reflected over like this? Or y equals 1. So you've got to be able to figure out, is it reflected over just a vertical line or a horizontal line? And there's no rule for that. So again, if you look at all the rules, the only rules are x-axis, y-axis, y equals x, y equals negative x. This doesn't follow any of those. There's no rule for this. So just very quickly, I'm going to visually try to walk you through, and I'm just going to do 1 point, because again, you only have to test 1 point. You don't have to test all 3. Whatever they do to 1 point, they're doing to all 3 points, or 4 points, or 5, or however many it is. So let's say we have a point here, we'll say. Yeah, we'll say. Let's say that's our point. And then let's say we're trying to figure out, is that point reflected over x equals, we'll just say 1. So I want to know, is the second point we have, so this would be -4, 2, and let's say the point that we're checking it with, like up here we had a second point, so let's say the point is -2, 4. And we want to know, and one of the options though in the question is it reflected over x equals 1? What does reflecting over x equal 1 mean? What did we say that earlier? You should have it in your notes from today. What's the line look like? Marquise?
You said over x.
Over x equals 1. What is that reflection line going to look like if we're reflecting it over?
It's vertical.
It's vertical, going right through what? What number? Vertical going through what number?
The x. Wait,
Give me a specific number.
isn't it going through that?
Yeah, 1 is what, is that what you're saying?
The point?
I'm going to write it. I'm not sure if you're saying this or not. So I'm just going to write it and you gauge whether or not you were getting it right. I need to draw, it is a vertical line. It's a vertical line that goes through x equals 1, which is right here. Kind of got off the line, but that's fine. So that's the line we're reflecting over, not the x-axis, not the y-axis. We're reflecting it over this green dashed line. So again, I need to figure out where would that reflected point be? Well, it needs to be perpendicular to that mirror line or that line of reflection, and it needs to be the same distance. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it'd be right there. So is that the correct answer? Is that the correct answer? Ciara, is that the correct answer? Did I reflect? So this was my original point,
Yeah.
and this is the second point.
But the two was a positive, now it's a negative.
Well, but I'm testing this right here. Did I reflect that over x equals 1? So this was my original point, and I said reflecting it over x equals 1 puts it right there. What is the coordinate for that point in green?
Well, if you did a little over.
I know, but I put it exactly where it should be.
And,
No, it is not correct. It is not. Because reflecting it, remember.
That was at the 4, that was at the 6.
Exactly. So it can't be this because my x value is 6, not 4. Does anybody have any questions on that? If you're flipping it, and remember, if you're flipping it over an x number or a y number, or the x-axis or the y-axis, one of the numbers will normally change pretty significantly because you've got to be the same distance away from whatever the line is. So that's how you would test it. You would probably just have to draw in whatever the line is, because there's no rule for it, and just do the reflection, whatever the rule is. In this case, it was reflected over x equals 1, and then see, well, is that the second point? So like up here, that would have been the second point I would have been checking with that problem. Here, this was the second point I was checking. Well, when I reflected over 1, no, that's not the point I get, so that can't be the answer. The actual rule would be what? Yeah, it would be y equals negative x? Yes, it would be. Correct. So if you look at the rule sheet, there is a rule that is on the rule sheet for this one. That's one way you may want to do it too. If you look at the rule sheet and there's not a rule that works, then you know it's got to either be this or something like this. Y equals some number. Because those are the only ones that don't have an actual rule. So you could check your rule sheet first. So I'll explain what I'm saying. So let's start over with the same point. Instead of maybe doing the reflecting over x and y first, check all your actual rules. So if this is my x and my y, whoops, and I had, what did I say, negative 2, comma, positive 4, right? Well, what happened? Who am I going to call on for this? I'm going to call on this Ariana. Ariana L. What happened? So again, this is my original x and y. I don't include any negative signs. What happened when they went from this original point, or this pre-image, to the image? What did they do? What changed? So what do you mean the numbers changed? How?
2 is now
So they flipped the order of the numbers, right? So we can go ahead and write that. We know they flipped the order. So we flipped the order. What else happened? Anything, or is that it?
2 is now.
They also flipped the sign of the first, or it was the second one, now it's the first one. So they also flipped the sign of that one. Anything else? Sure do. Look at the numbers. The sign of the force, that's the same.
Oh, no, it's not positive.
So they flipped the sign of both. We originally had a positive 2, now we had a negative 2. We originally had a -4, now we have a +4. So that is what the new coordinate looks like. They flip both of those. So now you could look on the sheet and see if you have a rule first. So try to find a rule for that first. And then if you can't find a rule that works for that, then you're going to have to go back and try to just do the other reflections over the X number or the Y number and see if that works. So check the rules first, like what, figure out what happened, create the rules. It went from this to that right there. So do that part first, check your rules, and then maybe if you find a rule, you don't have to try to figure out the whole reflection over a number part, which is a little trickier. If that doesn't work though, if you can't find a rule that matches up with what happened, then it's got to be X reflecting it over the X or reflecting it over the Y. Is there a question? Write this down. You talking about on the quiz or right now? No, you can do whatever you want right now. I mean that. He actually already said it. So the rule, by the way, if you didn't hear, the rule for this is reflecting it over Y equals -X. So if you want to look at that rule, you'll see for that one, what happens is they flip the order and they change the sign of both variables, which is what we just did here. We flip the order and we change the sign of both. Just remember, a negative sign does not mean you're making it a negative number. It means you're flipping the sign. So this negative doesn't mean that's a negative number. It means whatever the original number was, you're flipping the sign of that number. Like here, the original number was -4. The new number is +4. So we're flipping the sign of that number, which is what the negative sign means in that final step, the second coordinate, the image part. I do want you to understand, because there are problems where you will need to understand how to reflect it over X equals a number or Y equals a number. But I would say the better process is to check this first and then look at your rules, and you might not ever have to do that in some of the problems, but I think there might be 1 or 2 problems where you have to be able to do this. So again, if you want to reflect it over a Y number, we'll say, I'll make this one pretty quick. So if we have this point right here, and let's say we're reflecting that over Y equals 1. Well, Y equals 1 means a horizontal line. So you took the notes on this earlier, so I'm going to go pretty fast. So this would be Y equals 1. We're going to reflect it over that line. Well, all I do is I go perpendicular, which means straight up and down in this case. 1, 2, 3 away, which means I need to be 1, 2, 3 away up here. So that's a reflection over Y equals 1. And then the new coordinate would be the answer. So if this was 4, -2, this is, and again, my X value doesn't change. So that's one kind of hint when you're trying to figure out what the correct answer is did my X value change? Well, my X value didn't change, only my Y value changed. So 4, 4 is the new point, the new answer. If they gave you, sometimes they might give you 2 points and you got to figure out which line is the reflection line. Again, you're trying to take the point that's in the middle. Well, let me show you that real quick. So this is all recorded. Just keep that in mind. Let's say they gave you these 2 points. And they say, is that reflected over the X-axis, the Y-axis, Y equals X, Y equals -X, or X equals some number, or Y equals some number? You got to figure out, well, which one, is it reflected over the Y-axis, first of all? Is that a reflection over Y? Well, and again, I'm going to go through this. I see so many of you are tuned out, but we'll see how you do on the quiz. I don't babysit, especially on the first quiz. So if you're choosing to tune out, that's on you. There won't be any, well, never mind. So if I reflected it over the y-axis, I would just be right here. So that can't be right. If I reflected over x-axis, I would be down here. So that can't be right. If I reflect it over y equals x, which would be this line, well, I'd be down here because I have to be perpendicular to that line, which would put me down there. So that can't be right. If I reflect it over the y equals negative x, that would be there. So that put me over here. So that can't be right. So quickly, I've eliminated all kinds of answers. Yeah, go get her. So I'm down to really the only options are reflecting it over y equals a number and reflecting it over x equals a number. So only options I have left. Well, reflecting it over y equals a number would be a vertical line. Because if y equals a number, if y equals 5, that's my line. If y equals 1, that's my line. If y equals down here, that's my line. No matter what I do, I'm reflecting that up or down. Well, that's not going to get me over there. Moving it, flipping it up, or flipping it down is never going to get it over there. So reflecting it over y equals a number can't work. So I'm really just down to the last option of reflecting it over x equals a number. Because if I reflect it over a vertical line, that's just going to flip it straight left or right, which would work. I just have to figure out what is the line to flip it over. Well, I need to be the exact distance. Basically, I need the line that is right in the middle of those 2 points. Because I need to be the same distance from that line. Well, I can count my spaces. 1, 2, 3, 4, 5, 6 in between. So what's half of 6? Well, 3 is half of 6. So let me, and again, I don't go to the number 3. I need to count 3 spaces from one of the points. 1, 2, 3. So that should be my line right there. So, and again, I can just kind of check and make sure, well, am I 3 away or am I the same distance away from both sides? 1, 2, 3, yeah, 1, 2, 3, yeah, so there we go. So the final answer would be reflecting it over x equals 2. I don't know for sure if there's even one like that. I wanted to just get it on the video though, just to make sure the recording. But now let's go back and see what is on there for sure. All right, so you got to know how to do this. It says number 4, write a translation rule that can describe the result of a composition transition. So that's where we take a point like this. And it says translate. It's not transition. Sorry, that should be translation. So composition translation. Let me change that real quick. There. So a composition translation means what? Xavion. What's that mean? Composition translation. Probably not on that. We said composition means what? Do you remember, Rashonda? How about Josiah? Do you remember? Josiah. Ulysses, do you remember? Composition translation. So write this in your notes because it's looking like not many people remember. A composition of anything. It just means there's 2 of them. There's 2 transformations. In this case, they're both going to be translations, which you'll very rarely see. And this is the reason why you'll very rarely see it, what I'm about to show you. Normally, it'll be like a reflection and then a translation, or a rotation and then a reflection. In this one, though, we have 2 translations. What is a translation? Which What's a word that describes a translation? Slide. Good. What are you going to say? Slide. What's that?
Flip.
Well, flip is reflection. Translation is just sliding it. The image never spins, it never flips. It just slides from one spot to another with a translation. So let's look at, this is why you will really never see a composition translation, meaning two translations. Let's say we have this point right here. Again, you only need one point. They could give you a triangle, they could give you a figure. It doesn't matter. You're just doing the same thing to all of the points. If I say, and I don't remember what the original one said, but that doesn't even matter. Translate that point 1 and then 4. And then, because again, a composition means 2. Oh, I'm not writing out using terminology. And then translate it -3, 1. So what I'm doing first, and again, the order in this we'll say is this first and then this second. Oh boy, I got to get into that. Because this is not the actual, if I did the notation like this, boy, let me write this like this. Because remember, when we do the notation, you actually do the second thing first. So this would actually be this. We're doing this one first and then this one. Just remember that on the notation. If you get notation like this, you do this one first, then you come back and do the second translation. So I need to say, all right, well, first I'm going to take that point and I'm going to move it. Which direction? How many? Gabriel, you up? Gabriel, wake up, bud. You need to pay attention. Again, if you're awake and you're listening, that's fine. I need to move it 1, which is a positive number, and 4, which is a positive number. A positive x means to the right. A positive y means up. Right? So I would be moving it +1 and then +4. 1, 2, 3, 4. So I'd be here. So that would be my first translation. My second translation would then be -3 and 1, which means I need to move it left now, because -x means left. 1, 2, 3, but then still up 1. Now here's the reason why you'll never see it. Composition, is that what they use? Yeah, composition. Composition. I could have just said, well, wait a minute. If I'm just going to slide it from one spot to another spot, why don't I just figure out how far I moved it to get from here straight to here? Like, I don't need to go one place and then slide it to another place. Like, let me just say, well, how far did I go to get from here to here? So how far would that be? Like, if I wrote the rule to just do it in one step, what would that be? Who am I going to call on for that? Haley. I haven't called on Haley. What would my rule be? Instead of thinking, okay, well, first I'm going to go here, then I'm going to go here, well, what would I do just to go straight to that? What did I do to go straight to that point? What do you do? I got to go left and right first, and then up and down. So where do I go to get to that point? Is it to the left, or is it to the right of this original point? I'm going from here to here. Yeah, it's left, right? I don't go right to get to it. So I only go left and right and up and down. So if I want to go from here to here, but I got to go left and right and up and down, first I go that way, left 2, then what do I do? Oh, well then, Haley, you finish it off. Then what do I do? How many?
5.
Then I go up. 1, 2, 3, 4, 5, right? Well, left is negative. We just said that. So I go left -2. Up is 5. So there. I could have just used that. Oh, where's the path? I could have just gone to one translation instead of doing you had a bunch of them in there? No. Instead of doing 2 translations, I could have just used this one. Here's what it's going to say on the quiz, though. It actually tells you to do this on the quiz. If you'll notice, I didn't really have to go through all of this drawing and everything. I could have just added the numbers together. 1 plus -3 is -2. 4 plus 1 is 5. All you're doing is you're combining the translation numbers together. You combine the first one and the first one, the second one and the second one, and that gives you what the one translation would be. So if you can remember that, and it says it even on the quiz, but then you don't have to go through that whole exercise of drawing it out. If you want to draw it out, just make sure that's fine. Any questions on that? So that's a composition translation. So there's a question on partitioning a line segment. That's old material, like I said. You do have to do transformations on figures. If they give you a rotation, just remember, rotation in degrees is actually counterclockwise. So they give you some kind of rotation, whether it's in whether they verbally say rotate or whether they give you the actual notation like that. That means counterclockwise. So the opposite way of the way the second hand goes. Did you get that, Tiara?
I understand.
All right. A lot of you are saying that. I can't wait to see these quizzes. I mean, hopefully they'll be good. But I get kids saying that all the time, and then next thing you know, those quizzes, once you see all this stuff in front of you, people freak out. So remember that rotation is counterclockwise unless it's negative. So if it was a negative number, then it would be clockwise. And it says that probably on the rules. Does it? Oh, actually, the notation sheet probably says that. Yeah, the notation sheet will remind you of that. So the very first page reminds you of that for rotation. It says, it gives you a positive number, and it says that means rotate counterclockwise. Like on the example, it says rotate 90 degrees. Oh, and about the origin, I forgot that. It tells you in the quiz, I think it says about the origin. I don't think they even use that notation. Oh, if you need, so you need, I'm not going over it, but when you do a rotation about the origin, remember there's 2 ways to do it. You can use the rules, which are on the second page. So it tells you how to rotate about the origin. Or you can visually just spin the whole graph to see where that next image should be. But the rules work pretty well for that as long as you pick the correct rule. They don't really use the notation on the rules, so you got to be able to figure out what the notation means in words. You do need to know how to describe in words what a translation would be. So for example, move the pre-image 2 units to the right and 3 units down. Like that's what you have to know how to do, is to say it in words. So we talked about doing transformations. You're gonna have to do several of those. Oh, there is a problem, and it's just gonna be a bonus question, and I gotta figure out what it says, because in all honesty, it didn't copy very well. Neither of the bonuses copied very well. I can't tell what the sign is on it. Like I said, I got it from somebody else. I gotta confirm that. I think that's everything. You do have to know how to reflect a figure over, like y equals a number or x equals a number. That's probably one of the harder things. Remember, like I said, that rotating it. Oh, they didn't give you a very good term. Didn't give you a very good description on that. I'll remind you on the quiz. So there are some rotations. There's one goofy problem. I'll just explain that on the quiz. It's a word problem. Actually, there are a few word problems. One of them's easy. One of them's a little weird. All right, so that's everything. So if you have questions, now it's time to ask them. If you don't, then you can have some of you already been on the phone the whole class, so don't expect much from me tomorrow or in 2 days when you're not getting it. You got it down. 14 questions and 2 bonus questions. No. Oh, stop the recording. So I'll put this up at the end of the day. For me, the end of the day is 1:30. Well, do I have an appointment? No, I don't have anybody tutoring today, so.